Okay, guys, welcome to this lecture on modern cryptography. Okay, so just before starting on it, okay, just to iterate what we learned so far. Okay, so we learned first of all what is cryptography. Okay, what is classic cryptography? Thereafter, what are the various techniques under classic cryptography? Okay, such as Caesar cipher, okay, Wigner coding, okay, and things like that. Okay, after that we also learnt about an important period, okay, or an intermediate period that came as a revolution in the field of cryptography. Okay, and from there we are now here in the world of modern cryptography, guys. Okay, and this is the cryptography techniques that we use in today's world, okay, to secure our digital world. Okay, so now to start with, first thing I would like to highlight over here is that the modern cryptography is based on computer and mathematical science. Okay, so just after 19th century, okay, there has been a tremendous revolution going on in the field of mathematical science. Okay, in terms of various theories, algorithms. Okay, and which also led to the development of computer science very quickly. Okay, and as we saw in our last lecture that Alan Turing, okay, he was able to develop an electromagnetic machine to break down another machine called Enigma. Okay, and he's also referred to as a father of modern computing. Okay, so in a way the machine that he devised, it was also known as the first computer, guys. Okay, so all these things led to a very big revolution in the field of cryptography as well. Okay, and the cryptography which is now based on these algorithms, mathematical science, and computer science is known as the modern cryptography. Okay, and it's the foundation of today's digital security, guys. Okay, an important feature of modern cryptography is that it makes use of publicly known algorithms. Okay, so over here, guys, I want you to highlight the word publicly. Okay, so if you remember from our lecture on classic cryptography, that the methods of encryption or the methods of producing a secret message were kind of secrets. Okay, so they were not supposed to be known by other people, else they would break it easily, guys. Okay, that's what we discussed in our previous lecture. But on the contrary, in modern cryptography, the algorithms, okay, which are used for encrypting a message or creating a cipher text are actually known to the world publicly. Okay, however, a question might arise in your mind that if it is known publicly, then why we can't break it? Okay, the reason behind is that it involves tremendous amount of calculations. It is tremendously complex. Okay, and another major part of complexity is introduction of keys, guys. Okay, keys. Okay, secret keys to be more precise. Okay, and these keys are nothing but binary bits of data. Okay, what are binary bits? We all know that computer works in the field of 0 and 1. Okay, bits is the most smallest form of information block, and it can either hold a value of 0 or a value of 1. Okay, so keys over here are the inputs to these algorithms, guys. Okay, these mathematical and computer algorithms, okay, which lead to an encryption of a message or the decryption of a message. Okay, and keys are very big in size over here. Okay, keys are in sizes of 256 bits, 2048 bits, okay, things like that. Okay, so if these keys are inputted into an algorithm, guys, okay, it leads to tremendous amount of calculations. Like just to give you an idea, it may lead to trillions of calculations actually in case of some algorithms. Okay, and on behalf of these calculations, it becomes very difficult, okay, to know an output of an algorithm. Okay, because we don't know the key. Okay, although the algorithm is known to us, but we don't know the key. Okay, so key over here actually holds the secret, okay, or holds the mechanism for securing the information actually. Okay, and key is very much analogous to the key that you use to unlock your door, guys. Okay, so if you don't have the right key, you can't open the door. Okay, so in a similar way, in the world of modern cryptography, a key is a sequence of bits, guys, which is very important, okay, or very much required to decrypt a message if it is encrypted, or if to encrypt a message in the first hand. Okay, guys, so we can understand it in this form. Okay, now because of these keys being so complex, okay, because of these algorithms being so complex, so even though we know the algorithm, but it is impossible, okay, for a human being or sometimes for even a computer, okay, to break these algorithms. Okay, I would give you a small example just to get your brain fluids flowing. Okay, that there is an algorithm called RSA. We'll learn about that later in the lectures. Okay, it's an algorithm for asymmetric cryptography. Okay, now don't worry about these complex words, we are going to decipher them all for you. Okay, but for the time being, you just know that there is an algorithm named RSA, okay, which involves, okay, encrypting a message or decrypting a message. Okay, now to break that algorithm, if you don't know the key, okay, may involve 10 million years of calculation. Okay, now do you think that any human being on any computer in this world, okay, can break it for that long? Okay, or can exist for that long? Okay, so there where comes the power of these algorithms. Okay, so if you don't know the key, even though you know the algorithm, it's of no use to you. Okay, you can't break it actually. Okay, so that's the major part of modern cryptography, and here where it differs from classic cryptography, in the sense that in classic cryptography, the method of securing the message is not known or is a secret. Okay, but in modern cryptography, although the method is known, but still decrypting it is very difficult because of the fact of using of secret keys. Okay, so now coming to some of the aspects of modern cryptography, okay, some of the key terms related to that. So as the time evolved, the definition of cryptography has also undergone a change, okay, and now it's said that it's a process of designing a system, or to be more precise, a crypto system to provide information or digital security, guys. So we already learned about that the cryptography, the modern cryptography is the cornerstone of today's digital security world. Okay, so in our today's world, as you see around yourself, okay, we are surrounded by digital technologies, like if you want to send money to someone, if you want to receive money from someone, the various applications like Facebook, WhatsApp, they are all digital in nature, right? And securing these are very important in today's world. You don't want some hacker to hack into your Facebook profile, you don't want someone to enter your bank account on steal money, right? So it is very important to secure these services. Okay, and for securing these services, modern cryptography plays an important role, guys. Okay, now what is cryptanalysis? Cryptanalysis is the process of breaking the ciphertext. Okay, or process of decrypting the ciphertext actually. Okay, now comes crypto system. A crypto system is a system which has all the necessary components to implement a specific security service. Okay, now what's the security service we are talking about over here, guys? Okay, so we learned that we have applications like Facebook. Okay, so say for example, you have a security service to secure Facebook. Okay, so what are the components which are required to secure Facebook? That's what is called as a crypto system. Okay, now what are the components? We learned that in modern cryptography, encryption or basically securing of a message takes place using help of algorithms. Okay, so at the least we need three algorithms. Okay, one algorithm to encrypt the message, one algorithm to decrypt the message. By decrypting, I mean to to get back the original text from the cipher text. Okay, to get back the plain text from the cipher text. Okay, and we also need an algorithm to generate the key, guys. Okay, because key over here is very important in modern cryptography. So to generate it, okay, we need algorithms as well. Okay, and as a result of which it leads to a generation of a very complex key which is very difficult to first of all very difficult to comprehend and remember. It's not a key just like a sequence of characters, it's a key of sequence of bits, guys. So 0011 00001111 something like that. Okay, and when this key is inputted into an algorithm for encryption or decryption, okay, it leads to a very complex encrypted message in today's world, guys. Okay, which is very difficult to break, okay, even though you know the algorithm. Okay, so this system completely is known as a crypto system, okay, which is used to secure a specific service, okay, or to implement a specific security service, guys. Okay, so that's it, guys, from the lecture on modern cryptography. I think you are clear on this part what we discussed. Okay, and don't worry if you don't understand some concepts. Okay, because as we are going to move deep into the lecture, we are going to understand each and every part of it. Okay, so thank you, guys, for joining me in this lecture, and if you have time, please join me in the next lecture. Thank you.